Right, it's going to be recorded. Nice. So let's get started. There are a lot of slides to cover, and let's start right away. So let me introduce myself. I'm Jan, and I'm here to tell you the brief history of Unity test automation. Right, at Unity, we built one of the most challenging automation setup in the world. We run millions of tests on more than 25 platforms every single day, producing more than a couple of tens millions of runs. So in this talk, I will walk you through the history of our automation. So what we did right, and what is more important, what we did wrong. Right? You might ask, well, 25 platforms is not my case, so why do I need to listen to all of this? And the answer is that the chances are high that you will be going through the same mistakes we made. It's just our automation is under more stress, so we uncover more issues. So you will learn from our mistakes, and it's a unique opportunity. So, but before I tell you about automation, let me briefly introduce you to Unity. Unfortunately, I cannot see how many hands you can raise, so I assume some of you don't know what Unity is. So for those people, I will tell you that Unity is a game engine. It's known as a game engine, but nowadays it's much more. You can think of Unity as a platform for creating 3D content. You can take your content, animate it, make it move, dance around, do whatever you want it to do. So a lot of games are made with Unity, but Unity also finds itself in other industries such as architecture, automotive, and even movies industry. So the biggest strength of Unity is multi-platform support. So you want to make a game for Android, and then with a little of adaptation, it will work on many other platforms such as iOS and many others. And if we look at some of the famous titles made with Unity, you can see Meet Unity everywhere. This is a tweet from my colleague. He spotted Unity on his flight. But like about titles, so you can probably recognize some of those games, all of them, and much more are made with Unity. So Unity is a huge product, and the automation, it's a big challenge to develop Unity, and its automation is not an exception, right? So what makes Unity automation so challenging? There are several things. So first I mentioned is multi-platform. Well, I saw many automation setups in my life that failed on much less than 25 platforms, right? They couldn't run on 2 or 3 platforms, Windows, Linux, and macOS. And Unity runs on 25 platforms. It's a huge technical challenge. Then Unity is also a big product. It has many layers, and those layers are different by their nature. For example, inside core, which is in C++, you will use one testing framework which can work, where you can write tests with using C++. On the other hand, on more high levels, you can write tests in managed code, such as C#. So for example, like our users, they write their games in C#. So you can write your tests in C#. Or if you test rendering features, you might want to compare rendered image with a referenced image and see what is the difference and things like that. So the point is we have many testing frameworks for each such case, and those frameworks were not that unified back then. Right now they are, but we will get into it. And like usually, everyone tells about the test pyramid, that it should look like this. The most of the tests, the backbone of your testing should be fast, reliable unit tests. On top of them, you will do a bit of integration tests and then end-to-end tests, a very small amount. So the opposite of it will be ice cream cone, where the unit test is the smallest amount, but it's not the case for Unity. For Unity, it's been a different shape, but we actually never managed to measure what was this shape. But the fact is we had a lot of flow tests, right? So we, back in 2015, 14, we been about to learn how to handle slow tests. And that was our number one challenge. But beside that, there have been other challenges. Because we have this zoo of testing frameworks, it was hard to run tests locally. And therefore, it was hard to reproduce a failure locally. Say some tests failed on Android. How would you reproduce it locally? What do you need the Android setup on top of it? You need to know how to run tests on Android. So it was difficult. And of course, at such scales, when you have a lot of tests, you might see Flaky tests or flip-flopping tests, tests that fail and pass on the same revision. So what you're gonna do with such tests, right? And this is what we're gonna cover in this talk. But let's start with the slow test. As I mentioned, our test pyramid was a bit broken, so we had a lot of slow tests. For us, at some point, back in 2014, company was small, few hundred people, and we could afford it, right? We could spend a couple of hours running some extra tests, but company was growing, and it was growing very fast. And so at some point, we found ourselves in a situation where we could no longer afford to run all the tests on all the pull requests targeting release branches. So what did we do? We decided, okay, let's run less tests. And we split them in two sets of tests. First one we called a build verification, and probably we called it starting with letter A, then it shows up at the top of the web page, and nightlies. So for build verification tests, they were required to run on all the pull requests. And nightlies, no one ran them. They've been a set of slow tests, but we would run them every night. And that was a horrible decision for the reasons I am about to cover. So what happened? What happened is that people been running a lot of build verification tests, but no one was running nightly tests. So imagine you made a change, your pull request lands to a release branch, and then night after something fails. And that was probably because your pull request broke something and you didn't know what it was. So the way we decided to solve this problem is by introducing test scouting. So the idea was that, and remember, the company was still small. It's a few hundred people comparing to 7,000 today. So that solution kind of could work, but it didn't last long. So the responsibility of test scouting was to investigate the failures in nightly tests and then disable the test or reach a person who broke this test and like create defects and do a lot of housekeeping. And man, it was a hard problem. So the typical conversation was like this. So I would reach out to some developer and tell him or her like, hey, how are you doing? How is your daughter doing at school? Everything is all right. Is she still like music or what is she up to? Yeah, and he starts to tell me a story about his family, and then I tell him, hey, by the way, you broke this test. And yeah, this is what I had to do. So not a surprise, it wasn't very pleasant part of my work. I didn't like it, but I didn't see the way out. So the result of this effort was a lot of distractions because you had to spend 1 week, a month, or in 2 months to deal with these tests. And then we've been seeing that number of disabled tests was growing. And then very often root causes were not addressed. A lot of unstable tests, they signal us about some issue in the product, and that these issues were not addressed. We solved that problem, but how did we do it? I will tell you a bit later. So there have been a lot of demotivation. So about 6 months of this effort, I was very unhappy, and I was thinking to leave the company, and it was a bit tragic for me because except as scouting, this was the best and still is the best job in my life. So while I was upset, there have been other people who actually invented a solution, right? So hope came when no one expected. So what was the solution? And it's essential in understanding the how our automation evolved further. So the solution was, remember, we couldn't afford to run all the tests on all the pull requests. But what if we run tests on a group of pull requests, right? Say there are like 20 requests that are targeting release branch. What if we take 10 of those requests and run all the tests on top of them? So we call this group of requests a batch, right? So after we select a batch, then we could run all the tests on top of the batch. And what might happen that some of the tests will fail, right? For those tests, what we do, we find out like what pull requests introduce this failure. This is, by the way, how batch looks like. It's just a set of pull requests, right? So some of the pull requests fails. So what happens is that we kick out this pull request from a batch. So it's no longer targeting trunk. And then what happens when all the bad pull requests are kicked out from trunk? What we could do, we could land the good portion of batch into the trunk, and it's usually very expected event, and people put a lot of positive images under the message when which says that your pull request has landed. So that was good. That solved us the issue of slow test. Not that it solved that, but it made it tolerable. So we could continue develop, and we are not risking making regressions in the product because we made a couple previously due to the fact that no one been investigating failed nightly tests. So it was good. But what things went even better after that. So we kind of solved the slow test. But there have been another problem, right? How to run tests locally. The testing would require a complicated setup. And I realized it while I was working on a project for measuring code coverage. This project is um, not very active nowadays, but that's not the point. What I discovered during this project is that this is the command line how to run some of our tests locally. Those have been in unit tests. And well, good luck typing it on your keyboard and building all these DLLs and remember all these command line parameters. So our thoughts were like, could we make this command line somehow simpler, right? Can we simplify it so I don't have to memorize all of it? So this is how Unified Test Runner was born. This is a tool that abstracts all our testing framework. And you can just type UTR and then type suite and then say integration testing framework or graphics testing framework or native or whatever testing framework we have. So it was a great simplification. That was definitely a step forward. But what happened next is that we could run tests locally. But the issue still was that, if we go back to this huge command line, this is how our CI system been running tests. This is how it was set up. And we had like hundreds of config that been running tests using this command line, and people who've been running tests locally been using different tool. So this tool and the actual way of running tests been often out of sync. So we had to make tests to run the same way, both locally and on the build farm. And by the way, our build farm is called Katana. It's built on top of Google Build Board. So this is the only engine at that time that could scale to the size we need. Right now, we're moving towards our own CI system, but that's probably a reason for another talk. So we had to change a lot in Katana, which is the name of our CI system, to support this tool. But when we changed it, if something fails on Katana, then because the same tool is used on CI system and locally, then you could just grab the command line and run the test locally on your machine. So this way, we solved the problem how to reproduce a failure locally. But then even more good things started to happen because of that. So now we had a single entry point to run all tests at Unity. Well, not at Unity Engine. Nowadays, Unity is much bigger than Unity Engine. So at some point we decided, okay, so we have this single entry point. What if we streamline all the test execution data to some sort of a database? And we call this database and surrounding web services Hoarder. So the unified test runner run tests locally or on the build farm, and it sends data to a service, and then this service saves data to a MySQL database. Nowadays it's BigQuery, but it doesn't matter a lot. What matters is that test execution data is saved, and then we can analyze it. So this is how the analytics UI looks like. And in analytics UI, you could see a lot of information about tests. So you could see the past fail rate, how often test passes, how often it fails. You can see an average time, deviation from this time, and many other parameters. You can go to a test history and see where it fails, how often it fails. And we've been often discovering that tests they fail on the same build agent, right? So maybe there is something wrong with this build agent, and so on. So it was a nice start for moving our automation towards data-driven way of running tests. So other unexpected application of this tool was that, remember I've been telling you about graphics test framework, which we use in a way that we render an image, and then if we compare this image with a reference image, and if difference is big enough, how big it's configurable, then we could fail a test, right? But if you a graphic developer could, if you change some fundamental features, say font rendering, right? Then what do you do? You need to update hundreds of images because font shows up in many images, right? So using the Hoarder data, we could collect all the data about failed tests and present all the failed images on the same page. Then graphics developer would go through the tests, and he or she select observe the differences, and if everything is good enough, with a click of a button, images could be updated. So it was an unexpected application of this tool, but we keep finding more applications. Just for fun, this kind of an old photo, but it shows how many tests we've been running a day, per month, and in a year. But nowadays, the numbers wouldn't fit on this device. So, but what is important, we could make those tests, the test execution data visible. And because we had it in a database, other people could build dashboards and like see what are the most top slow tests. and they could ask questions. They could go to development team and ask, hey guys, like you're consuming 2 hours of Android device time every single day. Maybe you could fix it or simplify it. So this visibility, it really brought a lot of good things on the table. So what next? Remember, we introduced queue verification, but slow tests been still slow, and their number been still growing. So what we decided to experiment with, like, what happens if we find the tests that never fail? Like, we call them evergreen tests. And this is what is depicted on this screenshot, right? We can see the test pass ratio is 100% across 260, 600 runs. And what happens if we don't run this test? Well, it was a very good decision for 2 reasons. Remember, we had queue verification. For queue verification, we could still run all the tests, but for the pull request, we could run a reduced version of pass test. And by applying the simple rule, we reduce this is a set of random builders, but we reduce at minimum 50% of the time, and very few people being affected by the fact that we didn't run their test, but later on they would fail in queue verification where we would run all the tests. So it was a very good decision, anyways, and that shows how data could really help in many cases. Right now, we are moving towards more sophisticated machine learning algorithms. So instead of just blindly turn off evergreen tests, we would use advices machine learning algorithms would give us. So this way, we would know which tests will most likely to fail and which tests we should run first and what we should do about that. But we will probably do another talk about this. So we kind of solved all the issues we've been struggling, except flaky tests or flip-flopping tests or unstable tests. Many people call them different names, but that's not important right now. So how do we deal with flaky tests? So first of all, flaky tests is they're very frustrating, especially in our case. Remember, we had this queue verification. Your PR made it into a batch, but then due to a random test failure, you made a change in documentation, but some test in physics failed. And then your PR got kicked out, and well, you're not gonna feel very happy about that. So what did we do about it? So first thing we do is automatic rerun of failed tests, right? It's a tricky approach, but it worked very well for us. So how does it work? The unified test runner, which is our single entry point to run tests, it says, okay, test failed. Let's rerun it a couple of times. And if it passes on rerun, then we consider it that it passes, right? We will mark a build with some sort of a warning, but we will not fail it. And many people could argue that, hey, you're just hiding problems this way. It's not really a way to address issues. But actually, it is, right? If I made a change in documentation, why other pull requests would, why physics problems would hit me, right? It doesn't feel right. But what did we do also to ensure that instabilities and flaky tests are addressed? We changed our QA process in a way that all the issues connected to flaky tests, all the instabilities, they're given a high user pain. The user pain is something we use to assess the priority of the bug. So say there is a bug that Unity crashes on multiple platforms, right, it will have user pain. And if Unity crashes once a year on a single non-core platform, it will get less user pain. So this way we prioritize. And the instabilities and Flaky tests, they get a lot of user pain. So this way we make sure that they are all addressed. So we managed to get Flaky tests down by a lot. So, but we did it in a bit wrong way, because the way we did it, we've been actively monitoring the channels and see like which tests failing and what test people are complaining most about, and collaborating with teams, creating bugs. So in other words, it would require a lot of human interaction, right? And that wasn't that efficient. So at some point, the humans who've been doing this job been assigned to other projects, and the number of instabilities started to grow again, which wasn't great. So right now, we have a team, and I'm a part of this team that is working on Flaky tests, and we are moving towards no human needed to address Flaky tests. So how did we decide to approach it? First of all, instead of like trying to decide all the time which test is the worst Flaky test and which test we should spend our time investigating and developer time investigating, like we decided to go like data-driven on it. So we grouped all our tests, all our types of failures, and on this screenshot, the blue sector is the test failures. So they are about half of our failures. The rest of them are infrastructure-related failures, right? So, and out of those test failures, we know like what are the worst tests. So if we so we can see the list of tests, and for this particular example, we can see that this test on the top, it survives automatic rerun. So so remember, in the same build we do automatic rerun, and if test passes, then we consider build as passing. So in this case, it managed to pass inside single build 17 times, but it also failed 12 times. So maybe we should address this test first, right? So our idea is to eventually no human gonna be needed to maintain this effort. And right now we need to click a button. We can go to and see the history of a test. We can see the test name, how often it failed, and like if it appeared recently, we will have this nice check mark. What's the error message, call stack, and other things, which are very useful to have during the investigation. With a click of a button, you can create a bug, and then this bug will contain a lot of useful information, including artifacts and other things, like links to a wiki page, which contains all the root causes for instabilities people previously investigated, and stuff like that. So eventually, right now we need to press a button, so a bit of human judgment is required, but we are moving away from this. Then the bugs will be created automatically, and they will be closed automatically once instability is fixed. So that's how we currently deal with Flaky tests. So the tool provides more information. It shows like how many occurrences we saw per day and what are the builders that are affected by that particular instability, and so on. You can go and see the history, when it happens, and you can click on a build and go to our CI system and learn more on like what are the reasons why this particular test could fail. So this is the instability analytics tool, and we've been mostly focusing on tests right now because they are our biggest chunk. but what we're going to focus next, and it's our future, is infrastructure-related instabilities. Right? What do I mean by infrastructure? Say network failure. When network fails, like a lot of system components go out of order, and one of discovery we made was our source control system, right? That was very susceptible to network failure. So by adding retry to our source control operations, such as clone or checkout, we could reduce this type of instabilities to almost non-existence. But there are more instabilities. Sometimes we couldn't connect to devices, and because it's all happens all over the place, and it's not really aggregated to a degree we can bring it to development team. We need to invest some work into infrastructure failures. And like I said before, we gonna be doing our test automation even smarter by applying machine learning algorithms, but that is something I hope we gonna talk later this year or next year. Right now, I would like to wrap up this talk, and I would like to make some conclusions and summarize our mistakes. So it's not only mistakes, but also what we did right in a digestible way, right? So what went wrong for us, and it will probably go wrong for you if your automation is big enough. The pattern here is, and it appears in many other areas of our lives. Like one small bad things happen, we don't pay attention, and then another flow test appears, we don't pay attention. Another one, it's like cigarettes. One or two will not kill you, but if you keep smoking for a couple of years, like who knows what's gonna happen. And this is like very creeping pattern. So this way we let a lot of flow tests get into our automation. And luckily, we could afford to deal with those tests, right? Yeah, but not anyone could afford it. And sometimes I talk at conferences, and people tell me all sorts of crazy stories. Like I know a company, I'm not gonna name it, but they tell me, you know how we consider when our test pass, like if 60% of our test pass, then we think it's passed. So it's totally out of control. So automation and test code, and everything related to it, it should be like first-class citizen. It has the same value as the code, and it shouldn't be treated something else. So we should pay attention, and depending how much control or influence you have over your test automation in your organization, invest a lot into stability, keep an eye on slow tests, keep an eye on a stable test, and don't let them sneak in and ruin your automation. So with that, I would like to wrap up. And if you have any questions, I will be happy to answer.
I have a question regarding the PR batching. Could you elaborate on that a little bit more? How did you achieve that? And I mean, you just batch up some PRs, then you try to build and run the tests against them?
Yeah, let me go back a bit to the corresponding slide. It'll take a while. So this is, so we have a queue of pull requests that are targeting release branches. right? In this case, it's trunk, right? So, and we have people who are responsible for releases, so they usually do this job. So what they do, say you have like hundreds requests in your queue, right? You can take like 10 of them or 50 of them, and you call it a batch, right? So you couldn't run all the tests on all the pull requests in the batch, but you can run all the tests on the top of the batch. It means you merge all the changes and you run tests on all the, so you run on the top revision of this batch, which includes all the pull requests, right? And then if something fails, and presumably not many tests will fail, then we bisect this failure. So say this was a bad pull request, so it failed some of the nightly tests. And we run tests on a revision that corresponds to this batch, to this pull request, right? So we run it, it failed. Okay, we don't know where Tessa failed. So what we do, we start to bisect. And to bisection means like you need to search who introduced this failure, which pull request. So say, and the way you can do it, you can go one by one, or you can split your batch in half and then do a binary search. So say you found you run the failing test that failed on this pull request on another one on this one. Do you see my mouse, by the way?
Yes.
Yeah, so, and this one is green, right? It means that the failure comes somewhere here, right? Then you run your test here and then, okay, you found the bad pull request. And then what happens, and it's like really source control magic. I don't know much about it, but what happens is that you, as a developer, get this message, right, saying, hey, you introduced this failure, goodbye, fix it, and please come back next time, and your PR will be accepted in a batch once this failure is fixed. So this way, we run all the tests less times, because we save time by running them on a big batch of pull requests.
But it,
Yes.
sorry for interrupting, but it does not like interrupt the whole batch. I mean, it continues to run the test for.
Yes, exactly. So the trick here is that there is a possibility to land to. So it's this one using Mercurial. We're moving towards Git, but it's still in progress. We almost migrated all our branches, but there is a possibility to remove a certain revision from a special kind of repository, which is called draft repository. How it's done in Git, I don't know, but yes, it doesn't interrupt the batch. It just marks some of the pull requests as they're not gonna make it to release branch. And yeah, the interruption is not happening. And we can run many bisections in parallel. It's quite a complicated process, and there are a lot of things to. If you Google a path to trunk, I can write it in the chat. Unity trunk. Then there is a blog post which explains this process in more details. I hope that answers to some degree.
Okay, thank you.
You're welcome. Any other questions? All right. If there are no questions, or if you think about some questions afterwards, so that's how I always come up with questions, just too late. So feel free to reach me out. I'm on LinkedIn and Task. I will be happy to answer. And yeah, I hope you learned something new. And thanks a lot for your time. that's it.
Thank you so much.
Thank you.
Thank
You're
you.
welcome.
See you.
Bye.
Bye.
Thank you. Bye.